All right, I'm going to talk to you about data and some ways that we can analyze data and display data. The first way I'm going to talk about is a frequency table or a frequency chart. And the thing that I've noticed the most about a frequency table and chart with the students is having trouble setting the intervals. On your sheet, it may say something like start with 1 and it'll say width of 10. That just means that if you start with 1, you're going to go to where you want to include 10 numbers. And you may think that from 1 to 10 that it only includes 9, but if you think about it, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That includes 10 numbers. The width is how many numbers to include. If I said start with 0 and do a width of 5, that would be an interval of 0 to 4. Because 0, 1, 2, 3, 4, that's 5 numbers. That includes 5 numbers. So then my next interval would be from 5 to 9, because 5, 6, 7, 8, 9, that's 5 numbers. And then it would go from 10 to 14 and so on. For this particular example, I think doing intervals of 10 is most appropriate. So we are going to start with 1, and we're going to do a width of 10. So that means, so this is going to be scores. And you want to make sure you label your columns. And then this is frequency. Frequency is just the number of times that something happens or that it occurs. So I'm going to do, like I said, I'm going to start with 1 and I'm going to go to 10. Then I'm going to do 11 to 20, 21 to 30. Notice that my intervals don't overlap and that I'm including all the numbers here. 31 to 40. Actually, you know what? I don't even need to include all these. Let's just go. Let's see, the lowest number here is what? 65. So let's do 61 to 70, 71 to 80, 81 to 90, and then 91 to 100. So again, the frequency is the number of times that it occurs. So when I look for number 61 to 70, I've got a number here, here. So I've got 2 numbers that occur in that interval. From 71 to 80, I have 1, 2 numbers. From 81 to 90, I have 1, 2 numbers. And then I have 2 numbers from 91 to 100. So that makes it easy. Oh no, I have 3 numbers. Sorry. I have 3 numbers from 91 to 100. Okay? Now, the frequency table makes it really easy to get a histogram, to create a histogram. So I've got the same scores here, and I'm just going to create a histogram. And when I do that, again, you want to include a label, you know, something like test score, so some sort of title of the histogram. This is going to be frequency over here. Again, sorry about my handwriting. And then these are going to be the intervals of the scores. So again, my intervals were 61 to 70, 71 to 80, 81 to 90, and then 91 to 100. My frequencies were 2s and a 3. So I'm going to say 1, 2, 3, 4. I probably don't even need to go to 5, but I will. 61 to 70 was too high. 71 to 80 was also too high. Notice that histogram, the bars touch. 81 to 90 was also too high. I know this isn't to scale. And then 91 to 100 was 3 high. So again, a histogram just is a bar graph with intervals and your bars are touching. Now, the next thing we can find is mean. And mean is when you take all your scores, you add them up and divide by how many you add together. So here with these scores, I've got 85, 70, 78, 90, 100, 65, 73, 94, and 86. And so when I add them up, I get a total of 749. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9 scores. So I'm going to double check. You can see if you're using the class calculators in the window, you can still see your score. So it's a really good idea to go back and check. I think it's also a good idea, especially if you have time, just to go through and try it again. So this isn't a large set of data, so it's not a very big deal for us to go through and try it again. So let's try doing these again. So we've got 85, 70, 78, 98, 100, 65, 73, 94, and 86. And again, I got 749. And when I divide it by 9, the 9 scores, I get 83.2 repeating, which, remember I said we're going to round to the nearest hundredth place unless the direction said otherwise. So this rounds to 83.22. So the average here, the mean, is 83.22. Now the median is the score that's in the middle. When you're doing median, you have to make sure that you write your scores from smallest to largest. And so here, the smallest score is 65. Next we have 70. Then I have 73, and then I have 78. I have 85, 86, 94, 98, and 100. So I was running out of room, kind of crammed it there. All right, so the score that's in the middle, what you do is you start crossing off. I cross the lowest one and the highest one, then the next lowest one, the next highest one, the next lowest one, the next highest one, the next lowest one, the next highest one, leaving me with 85. So the median here is 85. If you have two numbers in the middle, like let's just say by chance 78 and 85 were in the middle, you would add them up and divide by 2 and find the mean of those two numbers, which is 81.5, and then that would be the median. But for this particular example, we had an odd number, so that meant that there was one number left in the middle. So the median is 85. Now, for a box plot, you need to know some information. You need to know quartile 1, you need to know quartile 3, and you need to know the median. And so we just found on the previous screen that the median is 85. So I'm going to go ahead and write that down. Now, what I can do is I can use these scores that are already written from lowest to highest. I can find quartile 1 and quartile 3. If you notice, here's the score. Notice I've got all these scores right here, and then I've got all these scores right here, right? This is the lower quartile, the quartile. So I'm going to figure out the middle of the lower quartile. And again, when I start scratching off my lowest and highest number, I have two numbers here in the middle. I have 70 and 73. Well, 71.5 is in the middle of those two. It's also the mean of those two numbers. So the quartile 1 here is 71.5. There's not a 1 there. 71.5. And then I'm going to do the same thing for the upper quartile. So I've got, across those off, and I've got a 94 and a 98 left. Well, 96 is in the middle of those two numbers. So 96 is quartile 3. So when you're making your box and whisker plot, you're going to have a number line, and hopefully yours looks a little bit nicer than mine does. We'll start with 60, and then we've got 70, 80, 90, and then we've got 100 here. Quartile 1 is 71.5. Quartile 3 is 96. And there's my box. And my median is 85, which is right here. My highest number is 100, so this is just going to come out a little bit. That's a whisker. And my lowest number is 65, which is going to come out to about right here. So there's my box and there's my whiskers. And it's not labeled, but we know that this is the lower limit, the lowest number, which is 65. We know this is our highest number, which is 100. We know that this is quartile 1, which is 71.5. We know that this is the median here. That's what that line stands for. And that this line stands for quartile 3. Now, actually, let me skip. Let's go to outliers. Okay. Outliers, sometimes you can look at a data set and you can tell right away. Like if you see a bunch of 5s and then you see a 60, that 60 is an outlier because it's not the same as all those other 5s. So sometimes it's very obvious to tell what the outliers are, but sometimes it's not. And so there is a mathematical way for determining what the outliers are, and that's the lower and upper boundary. So the lower boundary is quartile 1 minus 1.5 times the interquartile range. Well, the interquartile range is the difference of your quartiles. So it'll be quartile 3 minus quartile 1, which in this case is going to be 96 minus 71.5. And so if you put that in your calculator, you end up with 24.5. So the interquartile range is 24.5. That's the distance of the box. That's like from one end of the box to the other. So if I come back in here and I plug this in, sorry, I have to go back and see. Quartile 1 was 71.5. And then 1.5 times, the interquartile range is, we just said that, 24.5. But again, you have to follow order of operations. Wait, quartile 1 was not 71.5. I'm sorry. Yeah, it was. 24.5 times 1.5. And then 71. So we get 71.5 minus 36.75. And we get 34.75. So the lower boundary is 34.75. The upper boundary is quartile 3 plus 1.5 times the interquartile range. Well, we already said 1.5 times the interquartile range is 36.75. Quartile 3 is 96. So it's going to be 96 plus this. So it's 96 plus 36.75. And that is a whopping 132.75. So here is what this means. If the lower boundary is 34.75. If there's any score lower than 34.75, that score is an outlier. And when I look through this data, I do not see any number that's lower than a 34.75. Okay, so there's no outlier there looking at that. The upper boundary is 132.75, which, you know, on scores, you're not going to get anything higher than that. But just to double check, you go through and you look and you don't see any scores higher than that. That means that there are no outliers. Okay, there are no outliers in this data set because there's no numbers lower than the lower boundary or higher than the upper boundary. The next thing we're going to talk about is mean absolute deviation, which we call MAD. And so we already calculated that the mean was 83.22. Okay, so let me write that down. The mean is 83.22. So for MAD, what we do is we have to find the difference between the original score and the mean. And it's a distance. It's the absolute value. It's not going to be, you don't have negative distance, okay? So when I say 85 minus 83.22, I get 1.78. That's the difference between those two numbers. The difference between 83.22 and 70 is 13.22. Looks kind of funny. The difference between 78 and 83.22 is 5.22. Running out of room. 83.22 and 98 has a difference of 14.78. This is a difference of 16.78. Here we have 18.22. Here we have 10.22. Here we have 10.78. And here we have 2.78. Okay, so this is how far each of the original scores are away from the mean. Well, now we're going to add all these scores up. So I'm going to say 1.78 plus 13.22 plus 5.22 plus 14.78 plus 16.78 plus 18.22 plus 10.22 plus 10.78 plus 2.78 is, I get 93.78. But I'm dividing it by 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers, because there's 9 numbers in our data set. And I get 10.42. So this means that the mean of the original numbers is 83.22. The mean of the absolute deviation, meaning the average of how far they are from the mean, is 10.42, which isn't terribly high, but it's a little bit high. Because if you have numbers like, if I have, let's say I just give you 5 numbers. Let's say I give you 5, 6, 7, and 8. Okay, and I add them up, 5 plus 6 plus 7 plus 8, I get 26, and I divide it by 4, I get 6.5. So here, the mean is 6.5. Well, when I'm calculating the MAD, this one is 1.5 away from 6.5. This is 0.5. This is 1.5. And, I'm sorry. This is 0.5, and this one's 1.5 away. So the MAD, and I'm just doing this just to show you a smaller example. 1.5 plus 0.5 plus 0.5 plus 1.5 is, divided by 4 is 1. Do you see here, these numbers are all really close together. That's why the MAD is 1. So the mean of 6.5 is not far from any of these numbers. That's why the MAD is only 1. The closer the MAD is to 0, the less variance there is between the numbers. If all the numbers were 5s, the mean is 5, and the MAD is 0, because none of the numbers, all the numbers are 0 away from 5. So the closer the number is to 0, the less variance among the numbers there are. The larger the MAD is, the more variance there is in the numbers. And you can see here that these numbers vary more than these numbers do from each other. So what that determines, or where that comes into play, is when you're talking about mean or median. We found the median to be 85. And then the mean was, what was it again, 83.22? This one isn't too big of a deal as far as difference or anything, but because the MAD is kind of getting farther away from the data set, the median would be a better measure of the data. If the MAD is small, such as with this example here, then the mean would be a better discrepancy, or descriptor of the data set. So that's where that comes into play. So for this particular example, even though it doesn't vary by much, we would probably say that the median is a better measure of this data set. Okay.